Everybody, welcome to Math 70. This lecture video is for section 4.1, which is adding and subtracting polynomials. So polynomials are a certain type of mathematical expression. And before we talk about adding and subtracting them, let's talk about what polynomials are. A polynomial is an expression, which just basically means a mathematical word or sentence built from adding or subtracting powers of x. Now, the variable doesn't have to be x, but it's our most common. So let me give an example of just powers of x. We have just plain old x. That's a power of x. Technically, that's x to the first, but we don't worry about it. We just say x. X squared is a power of x, which means x times x. X cubed is a power of x. And we can keep going as high as we want. We can go x fourth, x to the fifth, x to the sixth, etc. Constant values are actually power of x because x to the 0 equals 1. And so that value 1 right there is actually power of x. Polynomials can only involve whole number powers. 1, 2, 3, 0, these are all whole numbers. If I try to put the power to equal 1/2, that's a power of x, but it cannot go in a polynomial. If I try to put the power of -3, that's a power of x, but these cannot be part of a polynomial because they are not whole numbers, 0, 1, 2, 3, etc. Okay, now that we've talked about what the powers are, let's build them to make a polynomial. So to make a polynomial, we simply add up powers of x. So let's pick as an example, let's add up a couple powers of x squared and x to the first. I'm going to take 3 of my x squareds and 1 of my x's. And remember, number 1 is also a power of x. So let's do 4 of those. But writing them like this is really inefficient. And so instead, if I'm going to have 3x squareds, I just write it as 3x squared. And I have a single x, and then I have 4. So this right here is a polynomial. 3x squared plus x plus 4. The numbers in front of x squared or x or any other power of x, etc., are called coefficients. So our coefficients here are 3 and also 1 because a single x would have a 1. The number, if there is one, without an x is called the constant because it never changes. No matter what value for x I choose, it will never change. So you can see as you think back to when we were solving equations, we were only solving linear equations, equations where there was only an x and a number. And now we're going to extend that to allow ourselves to involve other powers of x. The largest power of x in the polynomial is called the degree of the polynomial. And the degree is an important characteristic of a polynomial, which is why we give it a special name. So in this example, our coefficients are 3 and 1, 3x squared and 1x. Our constant is 4, and the degree is 2. So let me just do another example. Okay. With the numbers in front of the x, numbers in front of the powers of x, the number, if there is one, with the constant, and the largest degree of x. So here's an example. Let's do 7x to the fourth minus 3x squared plus 13x minus 2. Now, when I said adding powers of x, you can add negative amounts. And so minus is okay in a polynomial. We usually write it from the largest power on down, but we don't have to. We could write this as 13x minus 3x squared plus 7x to the fourth minus 2. It won't change the important pieces. It won't change the degree, and it won't change the constant if we write it in a different order. So let's find our coefficients. They are 7, minus 3, and 13. The constant term, which is minus 2 or negative 2. So if your constant term is a number that's subtracted, then we say the constant is the negative number. And the degree, which is the largest power, which is a 4. So the degree is 4. That's how we identify the characteristics of a polynomial. Each of these characteristics is very important. In this class, mostly we just need to learn what those are. But as you move on, you'll start to learn how we use these different characteristics to understand how the polynomial works. One more thing to say about polynomials before we get into adding and subtracting them, and that is, although the powers must be whole numbers, the coefficients, including the constant term, can be any number, any numbers. So here's an example of a polynomial. It's going to be negative 1/3 x to the fifth plus 1.02 x to the fourth minus 13x squared plus 0.001. I got all sorts of numbers for my coefficients, but the important thing is the powers are all whole numbers. Remember, if there's no x, that's like the power is a 0. So a not polynomial would be breaking one of our rules for our polynomial powers. And those are basically, if I have something that's a negative power, like 3x to the minus 4 plus x squared plus 2, as soon as I have one term that's not a whole number, it's no longer polynomial. If I have an expression where the power of x is in the denominator, also not a polynomial. And if I had a power that was not a whole number, like 1/3, also not a polynomial. So these three are not polynomials. Okay. Now that we know what polynomials are, let's start adding and subtracting them. How to add or subtract polynomials. The process is pretty straightforward. I'm going to illustrate it with an example that maybe might seem a little extra simple, but it illustrates the idea really well. I have 2 apples and 5 oranges. Joe has 4 apples and 10 oranges. If we add these together, what do we have? Well, I would say I have 2 apples and 6 oranges, and Joe has 4 apples and 10 oranges. And we're going to add those 2 quantities together. That should be a 5. 2 plus 4 is 6 apples. 5 plus 10 is 15 oranges. So we add the apples and we add the oranges separately. We don't add it all up and say I have a bunch of fruit. We keep our apples and our oranges separate. And it works the exact same way with a polynomial, except of having apples and oranges, we have powers of x. So when adding polynomials, and adding also includes subtracting, polynomials add different powers of x separately. These different powers are called like terms. So as a base example, if I have 3x squared plus x plus 7, and I want to add to that, let's see, 2x squared plus 4, I don't want to use 4, 6x plus 9, I would arrange them vertically just like I did with the apples and oranges. And I would arrange them so that the different powers of x are vertical, one on top of another, and then I just add them separately. 3x squared and 2x squared give me 5x squared. X and 6x give me 7x. And 7 and 9 give me 16. Other than some of my typos, that was fairly straightforward. So you just add the different powers of x separately. You add the like terms. And the easiest way to do this is vertically. Okay, let's look at another example. And this time I'm going to have some missing pieces. So let's do, for example, 5x cubed minus x plus 3. And I'm going to add to that x cubed plus 2x squared minus 4. And notice I have x cubed in both terms, but I only have an x squared in the second of the terms. And in order to keep track of that, I still recommend you do it vertically. Just leave a space for every power smaller than the degree. So if I have a 5x cubed, I'm going to leave a space for my x squared, and then my minus x and my plus 3. And that allows me to stack each of the like terms vertically. And if I'm missing a term, I just don't put it in there, and then it doesn't contribute anything to the addition. So I have 5x cubed plus x cubed gives me 6x cubed. Nothing on the top plus 2x squared gives me 2x squared. Minus x and nothing gives me minus x, and then 3 minus 4 gives me -1. So you can always add up polynomials in this vertical way, even if you don't have paired terms, just by leaving gaps so you can stack everything vertically. All right, let's do an example where we subtract polynomials. And let me do something like 5x to the fourth plus 4x cubed plus 3x squared plus 2x plus 1. And I'm going to take that and I'm going to subtract from it 2x to the fourth plus 3x cubed plus 8x squared plus x plus 3. And there's two ways you can do this. You can either do the subtraction of each individual piece. 5x to the fourth minus 2x to the fourth is 3x to the fourth. 4x cubed minus 4x cubed minus 3x cubed gives me an x cubed. 3x squared minus 8x squared gives me -5x squared. 2x minus x gives me positive x, and 1 minus 3 gives me a -2. So you can just move that negative through as you go, or before you do your subtraction, so that's option 1, you can take that minus and distribute it through all of the terms. So we have minus 2x to the fourth, and a minus 3x cubed, and a minus 8x squared, and a minus x, and a minus 3. And now it's addition, but I'm still going to get the same answer. I still get 3x to the fourth plus x cubed minus 5x squared plus x minus 2. So option 2 is to push that negative through and switch the signs on each of the terms so that you can add them. I'll do one more example, and that'll wrap it up for this video. It will also be a subtraction. Let's take 7x cubed minus 2x plus 1. And from that, we're going to subtract 4x cubed plus 2x squared minus 7x minus 3. So this combines a couple of our different ideas. The largest power is in x cubed. So I just need to leave space for every power less than that. I need to leave a space for my x squared term in the first one. And then minus 4x cubed. And then I have a plus 2x squared minus 7x and minus 3. So I could do 7x cubed minus 4x cubed. Nothing minus 2x cubed. Minus 2x minus -7x becomes minus 2x plus 7x. And 1 minus -3 becomes 1 plus 3. So I could do those step by step, but I'm going to instead choose to use option 2, where I rewrite my subtraction as an addition by distributing through the minus. So -4x cubed, and then -2x squared. Negative of a negative gives me positive 7x, and a negative gives me positive 3. And then I do the addition, and I get 7x cubed minus 4x cubed is 3x cubed, Nothing minus 2x squared gives me a minus 2x squared. Minus 2x plus 7x gives me positive 5x. And 1 plus 3 gives me positive 4. All right, that ends our video. Thanks for watching.